All right, I'm going to run a case for polyethylene. Now this applies to any type, whether it's high density, low density. You're just going to have to change the properties. You look up the properties that we look for and just change that. But the procedure is very, very easy. So we're just going to start up exploCFD. Did I click the right one? Okay. And I'm going to load a drawing. You can load your drawing. It doesn't have to be the same. Of course, always make sure there's no space in the name of the drawing. Don't click on it until it says not processed. While it's loading, don't click on it. If you do, then you have to restart the exploCFD again. Okay, exclude selected lines, exclude everything, and then we'll go here. We're going to just include a bay here. In fact, I'm just going to go like that. Include and include and include. I'm gonna maybe include these things here, and so we're gonna have the explosion sitting here. Okay, so let's see. Put an ignition point as per usual. How much polyethylene have we got? So that's the sort of footprint. You have to make sure that this size is correct. You know what the size of the drawing is, so you're able to measure. You know what the scale is, so you're able to measure the size of the footprint of the dispersed cloud of dust of polyethylene. So I've got here a cloud that's this big. I'm just going to say this is, I don't know, 10 by 10 meters. For me, I don't have to get everything. I don't have to get that number right, but you should. And just select the dust explosion. You just go, you put in the parameters here. I've looked up polyethylene here, and I think it's basically, I've got a KST value, it says here, where was it? KST value of 10, which seems high to me, but that's what it says here. So it's 10 bar, so it's very explosive. We said the vessel radius is about 5 because it's 10 by 10. Dust laminar burning velocity, you have to look that up. It should be around 0.5. You could just leave that. If you can't find it, it's very low. Usually, the laminar burning velocity of anything is usually half a meter a second or something like that, except for a couple of, ethylene is one exception, hydrogen is of course the other one. But it's best to look up the laminar burning velocity of the actual dust as a property. And that's it. That's all there is to it. You just close, perform analysis, and your results should come up. It gave me an internal pressure, I think, of 4.5 bar initially. I'm running very fast here. And we should be able to look at the results. In fact, let's do that. Let's look at the results. Go paraview, bin, start it. I really should have a shortcut for this. In fact, I think that's paraview. Let's load the files. So remember, it's under the name of the drawing in results in exploCFD. So it's called propane 3. I've got the latest one, that one, so 1040, and I'm running over here. Just load the results. And there you go. You've got the density, you got the pressure, you got everything. It's just that simple. Obviously my resolution is low, but that's not the point. The idea is, of course, how to run this. If you increase the resolution on the drawing here, change that to 300 by 300, for example, it'll run a bit slower, but you should get much more definition on the geometry. But that's the way it works. I've got 3.7 times 10 to the 5, which is 3.7 bar, which is about 2 bar. That's quite, it's serious pressure. That's it. Thanks for